For journeymen electricians, a comprehensive toolset is essential. Drills are paramount, including both a cordless drill with a minimum of 18 volts for versatility and a corded drill, either a half-inch or 3/8-inch model for sustained power in demanding applications. An impact driver, rated at 18 volts or higher, is crucial for driving screws and fasteners efficiently. A sawzall, which can be either corded or cordless, provides cutting capability through various materials. A grinder, also available in corded or cordless versions, is necessary for metalwork and material removal. A circular saw, again offered in both corded and cordless options, ensures accurate and straight cuts in wood and other materials. A reciprocating saw, similarly available in corded or cordless models, tackles demolition and rough cutting tasks. A multimeter, specifically a digital model from a reputable brand like Fluke, is indispensable for precise electrical measurements. A voltage tester, such as a Wiki or Volcon, offers quick and reliable voltage detection. Hand tools form the backbone of any electrician's toolkit. These include a hammer for driving and demolition, pliers encompassing needle nose, limens, and channel locks for gripping, cutting, and manipulating wires and components. Screwdrivers, both Phillips and flathead, are essential in various sizes for fastening and loosening screws. Wrenches, including adjustable and socket wrenches, provide the necessary torque for tightening and loosening nuts and bolts. A tape measure ensures accurate measurements for installations and layouts. A level guarantees plumb and level installations. A hacksaw handles metal cutting tasks. A utility knife serves various cutting and trimming needs. Safety gear is non-negotiable. Safety glasses protect the eyes from debris. Gloves provide insulation and grip. A hard hat, if required by the job site, safeguards against head injuries. For trainee electricians, the initial tool requirements are tailored to their learning stage. A cordless drill, either a 12-volt or 18-volt model, introduces them to drilling techniques. An impact driver is optional, allowing them to gradually incorporate specialized tools. A reciprocating saw is also optional depending on the specific tasks they're assigned. Hand tools remain fundamental. These include a hammer, pliers consisting of needle nose and lineman's pliers, screwdrivers in Phillips and flathead configurations, adjustable wrenches, a tape measure, a utility knife, safety glasses, and gloves, if required by the work environment. Several additional considerations should be factored into tool policies. Firstly, companies may need to mandate additional tools based on the specific types of electrical work they undertake, catering to specialized needs. Secondly, trainees typically begin with a limited toolset, gradually expanding their collection as they gain experience and expertise. Thirdly, it is generally understood that employees bear the responsibility for maintaining and replacing their own tools, ensuring they are always in good working order. Fourthly, the company might consider providing some basic tools, such as essential hand tools or safety gear, to employees who face financial constraints, fostering a supportive environment. Fifthly, the use of personal tools for company work should be prohibited, except in emergency situations, to maintain safety standards and ensure consistent tool quality. Regarding voltage testers, it's important to understand the differences between solenoid voltage testers, often called Wiki or Volcon testers, and digital multimeters. While a digital multimeter offers precise measurements of voltage, resistance, and current, a solenoid voltage tester provides a quick indication of the presence of voltage. Solenoid testers operate by using a solenoid that moves a pointer or indicator when voltage is present. They typically have multiple voltage ranges and provide a clear visual indication of whether voltage is present. Digital multimeters, on the other hand, display the exact voltage value on a digital screen. This is particularly useful when troubleshooting circuits and identifying specific voltage levels. The choice between a solenoid tester and a digital multimeter depends on the specific task. For quickly verifying the presence of voltage, a solenoid tester can be faster. However, for accurate measurements and troubleshooting, a digital multimeter is essential. Some electricians carry both types of testers to have the advantages of each. When selecting a multimeter, several features are important to consider. Firstly, voltage measurement capabilities are a must, encompassing both alternating current, abbreviated as AC, and direct current, abbreviated as DC voltage measurements. Secondly, current measurement capabilities, including both AC and DC current measurements, are essential. Thirdly, resistance measurement allows for testing the continuity of circuits and measuring the resistance of components. Fourthly, continuity testing provides a quick way to check for broken wires or open circuits. Fifthly, diode testing verifies the functionality of diodes. Sixthly, capacitance measurement assesses the capacitance of capacitors. Seventhly, frequency measurement determines the frequency of AC signals. Eighthly, temperature measurement, often achieved with a thermocouple probe, allows for temperature readings. Ninthly, auto-ranging automatically selects the appropriate measurement range. Tenthly, a digital display provides clear and accurate readings. 11thly, a backlit display enhances visibility in dimly lit environments. 12thly, overload protection safeguards the meter from damage due to excessive voltage or current. 13thly, safety ratings such as Cat Roman 3 or Cat Roman 4 indicate the meter's suitability for different electrical environments. 14thly, a ruggedized case protects the meter from physical damage. 15thly, battery life is a factor to consider for cordless operation. When choosing between corded and cordless power tools, several factors come into play. Firstly, power is a primary consideration. Corded tools generally offer more consistent power, particularly for demanding tasks. Secondly, portability favors cordless tools, allowing for greater freedom of movement on the job site. Thirdly, runtime is a limitation of cordless tools, dependent on battery capacity and usage. Fourthly, battery technology has significantly improved, with lithium-ion batteries offering longer runtimes and faster charging. Fifthly, weight is a factor, with cordless tools often being heavier due to the battery pack. Sixthly, costs can be higher for cordless tools, especially when considering the cost of batteries and chargers. Seventhly, maintenance is typically low for corded tools, as there are no batteries to replace. Eighthly, noise levels can vary between corded and cordless models. Ninthly, environmental considerations favor cordless tools, eliminating the need for extension cords and reducing trip hazards. Tenthly, application dictates the choice. Corded tools are often preferred for heavy-duty applications, while cordless tools excel in situations requiring mobility and flexibility. Regarding hand tools, it's important to select high-quality tools that are durable and reliable. Firstly, pliers should be made from forged steel with comfortable grips. Secondly, screwdrivers should have hardened tips and ergonomic handles. Thirdly, wrenches should be made from high-strength alloy steel. Fourthly, tape measures should have clear markings and durable housings. Fifthly, levels should be accurate and easy to read. Sixthly, utility knives should have retractable blades and secure locking mechanisms. Seventhly, hammers should have well-balanced heads and comfortable handles. Eighthly, hacksaws should have sharp blades and sturdy frames. Ninthly, safety glasses should meet ANSI standards and provide adequate eye protection. Tenthly, gloves should be appropriate for the task and provide sufficient protection. When establishing a tool policy, it's important to clearly define the responsibilities of both the employer and the employee. Firstly, the employer should provide a safe working environment and ensure that all tools are in good working order. Secondly, the employee should be responsible for maintaining and using their tools safely. Thirdly, the policy should address the issue of tool ownership and replacement. Fourthly, the policy should specify the types of tools that are required for each job. Fifthly, the policy should outline the procedures for reporting damaged or defective tools. Sixthly, the policy should address the issue of personal protective equipment. Seventhly, the policy should be communicated clearly to all employees. Eighthly, the policy should be reviewed and updated regularly. Ninthly, the policy should comply with all applicable safety regulations. Tenthly, the policy should promote a culture of safety and responsibility. When considering safety gear, it's crucial to select equipment that meets or exceeds industry standards. Safety glasses should conform to ANSI's IT 7.1 standards. Gloves should be appropriate for the task and provide adequate protection against electrical hazards, cuts, and abrasions. Hard hat should meet ANSI Society 9.1 standards and provide protection against impact and penetration. Hearing protection should be used in noisy environments to prevent hearing loss. Fall protection should be used when working at heights to prevent falls. Arc flash protection should be used when working on energized equipment to protect against arc flash hazards. Flame-resistant clothing should be worn when working in areas where there is a risk of fire. Safety shoes should provide protection against impact, compression, and punctures. Respiratory protection should be used when working in areas with hazardous air contaminants. Tool maintenance is essential for ensuring the longevity and reliability of tools. Firstly, clean tools regularly to remove dirt, grease, and debris. Secondly, lubricate moving parts to prevent corrosion and wear. Thirdly, sharpen blades and cutting edges to maintain performance. Fourthly, inspect tools for damage and replace worn or broken parts. Fifthly, store tools properly to prevent damage and corrosion. Sixthly, calibrate measuring tools regularly to ensure accuracy. Seventhly, replace batteries in cordless tools as needed. Eighthly, follow the manufacturer's instructions for maintenance and care. Ninthly, train employees on proper tool maintenance procedures. Tenthly, establish a schedule for regular tool maintenance. Tool safety is paramount to prevent accidents and injuries. Firstly, always wear appropriate personal protective equipment. Secondly, inspect tools before each use to ensure they are in good working order. Thirdly, use tools only for their intended purpose. Fourthly, follow the manufacturer's instructions for tool operation. Fifthly, keep work areas clean and well lit. Sixthly, never use damaged or defective tools. Seventhly, disconnect power tools before making adjustments or repairs. Eighthly, use proper grounding techniques to prevent electrical shock. Ninthly, never work on energized equipment unless properly trained and authorized. Tenthly, report any unsafe conditions or practices to a supervisor. When purchasing tools, consider factors such as quality, durability, warranty, and price. Invest in high-quality tools that will withstand the rigors of daily use. Choose tools from reputable brands with a proven track record of reliability. Look for tools with a comprehensive warranty that covers defects in materials and workmanship. Compare prices from different suppliers to find the best value. Consider purchasing tools in sets to save money. Read online reviews to get feedback from other users. Ask for recommendations from experienced electricians. When working with electricity, always follow safe work practices. Firstly, to energize circuits before working on them whenever possible. Secondly, use lockout/tagout procedures to prevent accidental energization. Thirdly, verify that circuits are de-energized using a voltage tester. Fourthly, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Fifthly, maintain a safe distance from energized equipment. Sixthly, never work alone. Seventhly, be aware of the potential for arc flash and arc blast. Eighthly, use proper grounding techniques to prevent electrical shock. Ninthly, follow all applicable safety regulations and codes. Tenthly, seek help from a qualified electrician if you are unsure about any aspect of the work.